Hey guys, I hope you're having a good Wednesday. I'm hoping our environment today is just going to be super chill, super relaxed, and that we're in our own zone, focusing, getting stuff done. Let's get started. Our target is today that we're going to be able to use function notation to represent a function. Remember, a function, one input has one output. The first thing that we need to know is what function notation means, and that just means it's a way that we represent y. So let me read this little paragraph to you as you're writing this down. The notation f of x is another name for y. If f is the function and x is the domain, then f is x represents the output, the range. Okay, x represents the input, f of x represents the output. F stands for function. You can use other letters, and we saw this a little bit yesterday, to represent functions, such as we'll see G and H to represent functions. Alright, I'm going to go ahead and move on to the examples. Please pause your video if you have not gotten all of this. Alright, our first one. Evaluate the function when x equals -4, 0, and 3. I want to talk about, I know you guys can do this stuff, I want to talk about what it's supposed to look like. I'm teaching you how to write in function notation, not how to solve these necessarily, because we've talked about them a lot. Okay, here's how we write in function notation. When we plug in -4 for x, this is what happens. F, I see x there, I'm going to plug in -4 equals 2 times -4 minus 5. Remember, this also just means y. Now we're going to solve. F of -4, y equals 2 times -4, -8, minus 5. F of -4, y equals -8 minus 5, -13. Function notation. The other way that you would write this, that you would see this, is if it said y equals, y equals, y equals. This is a specific y, so we like to use that function notation. Alright, let's plug 0 in. So if we plug 0 in, f of 0, because 0 is going in for x, equals 2 times 0 minus 5. Okay. F of 0, 2 times 0 is 0, minus 5 is minus 5. F of 3, plugging it in for x, 2 times 3 minus 5, 2 times 3 is 6, 6 minus 5 is 1. Here's function notation. Instead of saying y, we say the function when we plug in x, the function when we plug in x. Okay, let's go to number 2. G is another way we can represent this. So G of -4 equals -4 minus 1. Negative turns into a positive, and 4 minus 1 is 3. G of 0. -0 minus 1. 0 minus 1 is -1. G of 3. -3 minus 1 is -4. Alright, instead of writing y, we're writing it in G of, for function notation. Every input only has one output. Alright, example 3. Find the value of x so that the function has the given value. Okay, find the value of x. Find the value of x is flip-flopped this time. Okay, you see how it says f of x equals? That just means y equals 21. Y equals -1. So we're going to plug in 21 for f of x. So 21 equals 6x plus 9. Take away 9. Take away 9. 21 minus 9 is 12. Divide by 6. Divide by 6. And x equals 2. Alright, so when he says find for value for x, you're plugging in for y. When it says plug in x, you're solving for y. Okay, difference. Plug in for y, plug in for x. F of x means plug in for y. So plug in for y, -1 equals -1/2 x plus 3. Take away 3, take away 3, -4 equals -1/2 x. How do we undo a half? We multiply by 2, or divide by half, which you're going to have to copy dot flip. Okay, this needs to be negative, equals positive 8. All right, so a big thing between the first two examples and these two examples is when do you solve for x and when do you solve for y? All right. Example 5, graph the linear function. So I'm going to sketch, you're going to use graph paper and yours is going to be perfect, okay? So when we sketch this, you're still going to go down 2, and then you're still going to follow that slope of going up 3, 1, 2, 3 over 1. Okay, still going to follow that when you graph. That didn't change. Graph this next one. Still going to follow going up 4. Slope is up 4. And this, intercept is up 4. The slope is -1, so down 1 over 1. Still going to follow the same rules. Last but not least, go down 1, intercept down 1, and then we're going to go down 3 over 4. 1, 2, 3, 4. Down 3 over 4. So that all is the same. Awesome. Nothing changed there. Graph the function compared to the graphs. This is something we talked about yesterday. Compare to the graph f of x equals -2x. So let me just go ahead and I'm going to sketch this graph right here. F of x equals -2x. So treat it as if it says y equals -2x plus 0. All right, same thing. So intercepts at 0, go down 2 over 1, down 2 over 1. All right, here is the graph we're going to compare to. All right, let's compare this one. We graph it up 3. Now we're going to follow this up down 2 over 1, down 2 over 1. What happened to our line? This is something we talked about. It shifted. The line shifted up 3 because we added 3. Let's look at this next one. See, it went from 0, 0 to up 3. Okay, this one. We're going to go down 5, 3, 4, 5, and the slope is to go down 2 over 1. All right, we're no longer at 0, 0. We shifted down 1, 2, 3, 4, 5. The line shifted down 5. Because we took away 5, it shifted down 5. Because we added 3, it shifts it up 3. All right, we're ready for those on your owns. Go ahead and pause your video. I do expect to see f of x, not just y, okay? So remember, when do you plug in x and when do we plug in y? That's what you're thinking. And we're talking about a shift in the graph. So how does it move? Here's what we should have gotten. You should have paused your video if I'm going too quick. Here's what we should have gotten. For number 1, you were plugging in for x and then getting an output. Number 2, you were solving for x, so it should have said 8 equals -1/4 x plus 5. Number 3, you graphed them, and it shifted down 1 unit. Go ahead and answer that essential question, and your checkpoint's ready. I hope you're having a good day. Later.